What's secant? Anyways, what's secant x? We're gonna look at the graph of secant, cosecant, cotangent. What's secant? Yeah, so we know it's not an inverse, it's a reciprocal. Right? Cosine of an angle equals adjacent over hypotenuse. Secant of an angle would be hypotenuse over adjacent. It's reciprocal. It's a flip. We know cosecant's a reciprocal of sine. We know cotangent's a reciprocal of tangent. When I say the word flip, it's confusing, and it's my fault. Because like flipping with inverses and flipping with reciprocal things are different. When we say, hey, take a reciprocal, flip it, what does that mean? Like, for example, if I say, what's the cosine of pi over 3, and what's the secant of pi over 3? How do you get the secant of pi over 3? How do you get the secant of pi over 3? Find the secant of pi over 3. Go. How do you find the secant of pi over 3? Go. Yeah, please be locked in for 20 minutes. This is a short and easy lesson if you just pay attention. What's the secant of pi over 3? Go. Powerful. You think of pi over. Or pi over. Yeah, you think it's done. So neighbors, what's the secant of pi over 3? It's the cosine of pi over 3 flipped. Now, we're not flipping a's and b's. We're not flipping x's and y's. We're flipping fractions. We're taking the reciprocal of the fraction. Reciprocal. All right, tell me, what's the secant of 0? The secant of 0. It's not pi over 2. Now you're starting to think about inverses, and it's like we're out of inverse land right now. We're talking reciprocal land. What's the secant of 0? The secant of 0 is 1. The cosine of 0 is 1. We're just in triangle unit circle land. If we flip 1, we get 1. All right, cool. What's the secant of pi over 2? What's the secant of pi over 2? What's the secant of pi over 2? What's the secant of pi over 2, Murph? Undefined is correct. The cosine of pi over 2 is 0. The cosine of pi over 2 is 0. Hypotenuse, or adjacent over hypotenuse, 0 over 1. Secant of pi over 2 is hypotenuse over adjacent. We talk about our hypotenuse always being 1. So this is like 1 over 0. 0 flips, becomes undefined. Now, it might seem obvious, but hopefully if you just understand this, you're going to understand this lesson and why it's easy. What happens when you take the reciprocal of half? 2. That means you take the reciprocal of 2, you get a half. What happens when you take the reciprocal of 1 over 1,000? We get something that's very big. You get something very close to 0. Flips become something very big. Something very big flips. Gets something very close to 0. Cool? Cool? What happens when we flip 1? It's 1. What happens when we flip -1? G Ford, what happens when you flip 0? What's the secant of pi over 2? We're going to say we get undefined. You think about zeros being 0 over 1. You think about flipping that, you get 1 over 0. Okay. We're going to start with the graph of just cosine. You guys remember how to graph cosine? Well, I'm going to remind you really quickly. Do it over here on the right. And yeah, honestly, you should have done it on the quiz. Like to graph cosine inverse, I'm going to start with the graph of cosine. Because like, I'm just going to take the points on the graph of cosine and flip it to find the graph of cos inverse. But now let's look at the graph of the reciprocal of cosine. Let's look at the graph of secant. Again, it's not inverse. So I'm going to start at 0. I got pi over 2. I got pi. I got 3 pi over 2. I got 2 pi. We have y values of 0, y values of 1, y values of negative 1. Right? Right? Cool. Now, understanding that secant x is 1 over cos x. X's are x's. Inputs are inputs. We don't have to flip inputs. We don't have to take reciprocals of inputs. They stay our inputs. However, the y's on secant are the reciprocal of the y's on cosine. The y's for secant are reciprocals of the y's on cosine. The secant function is the reciprocal of the cosine function. The y's on the secant graph will be reciprocals of the y's on the cosine graph. Okay. I have the graph of cosine right here. This is the graph of y equals cos x. And this is what you're going to do to graph secant and cosecant. We are going to graph secant right on top of the graph of cosine. So if you have a different colored pen, break it out. We are going to graph secant on top of the graph of cosine. All I'm going to do is take the y values that I see and find the reciprocals of them. So, Blanchard, what's this y value here? Flip it. What do you get? Take the reciprocal of it. What do you get? Great. So, here is a red dot on the graph of secant that's still on the same dot as the graph of cosine because 1's reciprocal is 1. Here's a point right here that is like the cosine of pi over 3. The cosine of pi over 3 is a half. Okay, sorry, I didn't want to do this in red. This should not be in red. Okay. This is a point on the cosine graph, pi over 3 a half. If you took that y coordinate and took the reciprocal of it, flipped it, what would you get a y coordinate of? 2. So this point, which has a y value of 1/2, flipped becomes a y value of 2. Okay, so we're above like the top. Let's skip some points and go right here where the y coordinate is 0. What is the reciprocal of 0? What does that look like on a graph if we get undefined? We've seen it before. Very good. We have now a vertical asymptote. Okay. What do we have here? I don't know, but it's very close to 0. It's a y coordinate that's a very, very tiny decimal, like 1 over 1,000. What happens if you take the reciprocal of 1 over 1,000? It becomes 1,000. All of a sudden, we have the idea of a asymptote. Cool.
I have a question, Spencer.
Yep.
So why is that 0 on the y-axis, not a horizontal axis?
Because what's the cosine of pi over 2? Just 0, right? What's the cosine of 3 pi over 2? Just 0. So it's an actual point. Okay. Could you keep going? Go. Try. I'd like you to all try. Keep going. Think about flipping or the reciprocals of all of these y coordinates. Take the reciprocals of all these y coordinates and see if you can come up with the rest of the secant graph. Please. Please. This will be very easy if you just pay attention and try. Take all of these y values and flip them. What does that look like? See if you can do it. Start with the easy ones. -1 flips. 0 flips. It's not easy, but like, hopefully you understand it. 1 flips. Now, the tricky ones is the fact that all of these values here are between 0 and -1, which means they're like fractions. This is -0.5, this is -0.5. This is a value that's very close to 0, like -1 over 1,000. This is a value very close to 0, like -1 over 1,000. Go, give it a shot. Come on, guys. So many of you are like, nah, I don't want to try because I might get wrong. No. The x's stay the x's. It's the y's that we take the reciprocals of. Don't flip the x's. This is not like inverses. This is different. Oh, gosh. All right, whatever. Here you go. Pay attention. What's the secant of pi? It's -1. Why? Because the cosine of pi is -1. What's the secant of 3 pi over 2? Undefined. Why? Because the cosine of 3 pi over 2 is 0. What's the secant of 4 pi over 3? Well, it's going to be -2. Why? Because the cosine of 4 pi over 3 is -0.5. -0.5 flips, -2. What's the secant of, sorry, that's 2 pi over 3. 2 pi over 3 secant is -2. 4 pi over 3 secant is -2. These y values are getting flipped. This y value, very close to 0 and negative, flipped, very, very large and negative. This y value, very close to 0 and flipped, very large negative value. All of a sudden you get this kind of upside down parabola. Many people don't expect it, but if you just think about taking your y values and flip it, should make sense. Take this y value, which is below 0, flip it. It becomes a very large negative value. Take this y value of 1 and flip it. It stays 1. Take this y value, which is very close to 0, but it's positive, and flip it. And it becomes a very large positive value. You don't memorize this graph. You understand this graph. You guys understand cosine x's graph, hopefully. Maybe you have this one memorized. You don't memorize secant's graph. You understand why secant's graph fits on top of cosine's graph. You understand why secant's graph fits on top of cosine's graph the way it does? Explain to your neighbors so that you learned something today. Why does secant's graph look like that? And why does it fit on top of cosine's graph like that? Go! Okay. Okay. Guys, I'm not going to get into sine and cosecant. Because sine and cosecant is the same thing. You don't memorize the graph of cosecant. You see the graph of sine. You see the graph of sine? Wherever you see a 0 on sine, it turns into a vertical asymptote on cosecant. Wherever you see a 1, it stays a 1. Wherever you have fractions between 0 and 1, flipped becomes y values between infinity and 1. Whenever you see decimals that are negative between 0 and -1, you will get these values that are larger in the negative direction than -1. You don't memorize this. You understand why cosecant's graph fits on top of sine's graph, because they're reciprocal. The one that is a little bit funky and people don't see it is cotangent. Okay? Now, secant, cosecant, it's cool. You know what sine and cosine look like, and you understand about reciprocal. Let's try cotangent. We're going to graph it on top. We're going to graph cotangent on top of tangent. Let's start with tangent. You guys remember the graph of tangent? Go. All right. Ready? Here we go. The tangent of 0 is 0, opposite over adjacent, OA. The tangent of pi over 2 is undefined. As I get closer to pi over 2, the opposite's getting larger, the adjacent gets smaller, which is why our resultant ratio trends towards infinity. In the second quadrant, tangent's negative, but again, we have an OA. That's going to be a big O and a very tiny a, which is why I'm coming from negative infinity. Pass through 0 in the third quadrant. As we get closer and closer to 3 pi over 2, the O gets more and more negative. The A gets less and less negative. Negative divided by negative, positive, trending towards infinity, and then we go this way. Cool? Now we're in the fourth quadrant. Okay. Flip these y values. What does it look like? What happens when you flip 0? Let's start with that. All right, so all of a sudden, we have vertical asymptotes that are over here, and over here, and over here. And I will highlight this so we can see the difference. Here is now vertical asymptote, vertical asymptote, vertical asymptote. Here's a new one. Flip a vertical asymptote. Turns into a 0. Okay, well now we have a 0 here and a 0 here. Okay, now here's where it's going to be tricky, because a lot of people are like, okay, I got it. Yoink, yoink, and you're wrong. Flip this positive tiny decimal. Big positive. Flip this positive large number. Flip 10,000 What happens when you take the reciprocal of 10,000? You get 1 over 10,000. So you might think it goes up, but no. When you take the reciprocal, it actually goes that way. Small decimals, reciprocal, large numbers. Large numbers, reciprocal, small decimals. Okay, what about between here and here? What's it going to look like? Large negative number, reciprocal, very small, close to 0, negative number. Small, close to 0, negative number goes to a very large negative number. So here is my graph of cotangent. Now, you don't have these memorized, guys. You don't. You have the parent function, sine, cosine, tangent. Those you have. And then you understand about taking reciprocal. Now, it gets to the point where you're going to have questions like, hey, what's this graph look like? This is the last thing I'm going to do. The last thing I'm going to do. You don't go straight to this graph. You graph its reciprocal, which we've done so many times. Now, this requires us to do a little bit of reviewing. All right, Ford, what's the 4 going to do? Great. Blanchard, what's the negative 5 going to do? Okay, good. So we got a negative 5 as my midline. I'm going to go up to negative 1. I'm going to go down to negative 9. What's the minus 3 do, Collie?
Minus 3.
Yep.
Move the entire graph to the right grid.
Good. So we have a new phase shift of 3. Lazara, what about that 2 pi? What's that 2 pi going to do? Yeah, Murph can answer it for you. Yeah, you can't answer for yourself. It's okay. It's all right. It's okay. 2 pi. Here you go. There's 2 pi right there. Right there. Right? No, come on, Lazara. Murph, you want to answer for him? Go ahead. Murph, what's the 2 pi do? Yeah, it affects the period. 2 pi over b means the period is actually 1. Remember, we stepped this out by dividing by 4. So this is 3.25, 3.5, 3.75, 4. We have the graph of cosine, which starts at the top, goes to the midline, goes to the bottom, goes to the midline, goes to the top. You guys good with that? Now, thanks, Barry. Guys, if I'm asking you to graph secant times 4 of 2 pi, t minus 3 minus 5, you start with cosine. Could you take the reciprocal of this graph? Negative 1 stays at negative 1. Negative 9 stays at negative 9. That stays there. The zeros become asymptotes. The fractions will become big numbers, whether they are in the positive or the negative direction. What you will see is that if you know sine's graph with all of its adjustments, you will know cosecant's graph with all of its adjustments. And then you can answer any question that comes at your way.